Have you ever wondered what quantum computing is all about? In this video, we break down the complex concepts of quantum computing into easy-to-understand terms using simple analogies and animations. Forget everything you know about classical computers and get ready to enter the weird and wonderful world of the quantum realm. We'll explore the basics of qubits, the mind-bending principles of superposition and entanglement, and how these concepts could revolutionize technology as we know it. For decades, our world has been powered by classical computers. They speak a simple language, a world of zeros and ones, of on and off. This binary system has been incredibly powerful, taking us from the first calculators to the smartphones in our pockets. But what if we could compute in a way that's fundamentally different? What if we could solve problems that are currently impossible for even the most powerful supercomputers? Welcome to the world of quantum computing. To understand quantum computing, we need to meet its fundamental building block, the qubit. Unlike a classical bit that can only be a 0 or a 1, a qubit can be a 0, a 1, or both at the same time. Think of it like a spinning coin. While it's in the air, it's neither heads nor tails. It's in a state of all possibilities at once. This is a key principle of quantum mechanics called superposition. Because a qubit can exist in multiple states simultaneously, a quantum computer can explore many possibilities at once. 2 qubits can represent 4 states at the same time. 3 qubits can represent 8, and so on. This power grows exponentially with each new qubit you add. Now here's where things get even stranger. Qubits can be linked together in a special way called entanglement. When 2 qubits are entangled, their fates are intertwined. If you measure one and find it's a 0, you instantly know the other is a 1, and vice versa. This connection holds true even if they are separated by vast distances. Einstein famously called this spooky action at a distance. Imagine trying to find your way through a giant maze. A classical computer would try every single path one by one until it finds the exit. A quantum computer, using superposition and entanglement, is like being able to explore all the paths at the same time. This allows it to find the solution exponentially faster for certain types of problems. So how do we build these incredible machines? Quantum computers are extremely delicate. Qubits are very sensitive to their surroundings, and any disturbance, like heat or noise, can cause them to lose their quantum properties in a process called decoherence. That's why they are kept in super cold refrigerators, just a fraction of a degree above absolute 0, to protect the fragile quantum states. Scientists use precisely controlled lasers or microwaves to manipulate the qubits, putting them into superposition and entangling them. These operations are like the logic gates in a classical computer, but they work on the strange rules of quantum mechanics. The power of quantum computing isn't about making your video games run faster. It's about solving problems that are currently intractable for classical computers. For example, quantum computers could revolutionize medicine by helping us design new drugs and materials at the molecular level. They could create new financial models to better understand the market and optimize investments. They could also break many of today's encryption methods, leading to a new era of ultra-secure communication. It's important to understand that quantum computers won't replace our everyday computers. Instead, they will be specialized tools for tackling specific, incredibly complex problems, working in tandem with classical machines. Quantum computing is still in its early days, much like classical computing was in the 1950s. But the progress is rapid. Researchers and companies around the world are in a race to build more powerful and stable quantum computers. While we may not have a quantum laptop anytime soon, the journey into the quantum realm has begun, and it promises to reshape our world in ways we are only just beginning to imagine. Thanks for watching Bitewise, where complex tech meets simple explanations. If you enjoyed exploring the quantum realm with us, hit that like button, subscribe, and join our growing community of curious minds. Until next time, keep thinking in bytes and dreaming in quantum leaps.